Hi, I'm Toby Kaplan, and for more than 30 years I was a classroom teacher and a mathematics coach. Now I'm working with Symphony Math. We're going to look at a routine today, and it's a routine you can do with your whole class, a small group, one-on-one, and you can also use it remotely. It will take about 15 or 20 minutes of your class time, and it works with any Symphony Math content. The goals of the routine will be for students to understand the content in a more deep way. Today it will be multiplication, as well as have some practice with the skills. And additionally, students will be making models, stopping, reflecting, and then communicating what they think. In this way, we think students can develop a deeper understanding and have more ownership over their math. We are going to be looking at stage 13, which is multiplication. Students can build on what they've been doing with skip counting and adding groups together. And instead of the additive understanding of mathematics, we're now looking at the multiplicative relationship. The multiplicative relationship forms the basis of repeated equal groupings and our entire place value system. It's the basis on which our whole numbers and our decimal numbers are built. You can find out more about repeated equal groupings if you looked at the Symphony Math support page under Scope and Sequence. We're going to be using one of the models that is consistent through Symphony Math, and today it will be the number line. We find that the number line is a good thinking tool for students, and we want them to understand that jumps of equal groups on the number line can be the equivalent of equal groups. So you will need a number line, number cards, the multiplication sign, the equal sign. I'm going to show you a task and model how I might present this to students. Here we go. We've been working with adding numbers, and we're starting to multiply numbers together. In this situation, we have a number line, and the conditions say 7 jumps of how many make 7. Okay, I see this number line is ticked off by ones, and we want to make 7. I'll just put a mark here so I can remember 7 is the total. We want to get to 7. I know I need 7 jumps because that's what it says. But I don't know how large to make each jump. I don't know the size of the jump. Well, I'll try something. I know how to count by twos. So what if I started jumps of 2? I could go 2, 4, 6, In only 4 jumps, I'm already too high. I need 7 jumps and I need to make 7. Okay, that's okay. Why don't I just start again? Making a mistake is fine. But now, if I adjust my thinking, I know 2 is too many. So I think I'll do jumps of 1. Let's see how this works. Well, here would be a jump of 1, 2, 3, 4, 5, 6, 7. Forgot to do that, but I did want to make it to 7. And I see that I have 1, 2, 3, 4, 5, 6, 7 jumps. That's what it says. I want to make 7. So each time I jumped 1, 1, 1, 1, 1, 1, 1. I think I satisfied all the condition. 7 jumps of 1 make 7. What do you notice? What do you wonder about? Let students do some quiet thinking to themselves and just stop and reflect on what they see. It may not be apparent that the jumps mean groups of, so we want to give students a chance to wrap their heads around that. Once they've had a chance to share, don't stop them or correct them, just let them talk to each other and tell you what they see. Let's do the next step. I want to make a number sentence that matches this number line. Okay, well it says here we have 7 jumps, and we've determined that yes, we have 7 jumps. I'll put my 7 here for that. 7 jumps of how many? Okay, I make 7 jumps, but I didn't know yet how large to make the jump. It was 7 times some quantity that we did not know. We didn't know the size of the jump, but we knew we wanted to make 7, so we knew it would equal 7. We did determine, first by making a mistake, and then by figuring out, well, 2 was too many, so let's do this by 1, that in fact 7 times a jump of 1 does equal 7. Or 7 groups, because the jumps are groups, of 1. Each group is the same. 7 groups of 1 does equal 7. And we say it, 7 times 1 equals 7. What do you notice? What do you wonder about? The numbers, factors of 0 and 1, can often pose some problems for students. 1 is very important in multiplication. It is the identity number. 1 times any number returns that number. But it does probably look a little bit strange. I mean, students don't go around saying, I'm 7 1s-year-old. But that is what we're counting by. So see if students have anything to say about jumps of 1. Some questions you can ask them to make sense of what they're doing are, how is the number line helpful for thinking about this problem? How is a number line helpful for solving this problem? Did you know how many groups you had or how big each group would be? How did we know where to stop? Let the students know you want to try one other with them. This one will be a story problem. Story problems give a context, which is very important for math. It can help them anchor their thinking if they have something to attach the numbers to, so they don't just go and operate on the numbers that they see. Let's try a number line to solve a story problem now. Here's the problem. Kenny can swim 6 laps a day at his town pool. This week, his goal is to swim 30 laps altogether. How many days will it take Kenny to swim a total of 30 laps? Well, let's see if we can make some sense out of this story problem. What we know is that Kenny can swim 6 laps a day. So that means every day he's going to swim 6 laps. We also know that his goal this week is to swim 30 laps in all. Let me put a marker here at 30. Also notice, in this case, we skip count by 5s on this number line. Since Kenny can swim 6 laps a day, I may not know exactly where 6 laps is, but I can use what I understand about these numbers to place his laps. What I have to figure out is how many days will it take Kenny if he can swim 6 laps a day to make 30. Well, in this case, I know how much he can swim in one day, and I'm going to show that with a jump. Here's 5. We know that he can swim 6 laps a day. So that will be 6 laps. All right, got a long way to go here. I know 6 and 6 makes 12, which would be about here, or past the 10. Let's say that's about 12. That's another 6 laps. My number of laps has to be the same, still not here. I know 6 and 6 and 6 are 18. Well, that's right here before 20. Am I exact? No, but I think I'm close enough. And I know that I need to get to 18 here because 6, 6, and 6 make 18. Another 6, 4 6s, get me to 24. So 6, 12, 18, 24, we're not there, but another group of 6 will take us right here to 30. And I can see 6, 12, 18, 24, 30, or 1, 2, 3, 4, 5 groups of 6 makes 30. So swimming 6 laps a day, here are the 6 laps a day, times 1, 2, 3, 4, 5 days, it takes Kenny 5 days to make his 30 laps in all. What do you notice? What do you wonder about? In this problem, we knew the size of each group, which was the 6 laps, but we didn't know how many groups we needed. That is often problematic for students. Hopefully the number line will show them that by counting by 6s, it helps them think of a way to see how will they get to 30. Let's see if we can do a number sentence now. Let's make a number sentence that matches this situation and this number line. What do we know? Well, we know Kenny can swim 6 laps a day. Okay, but the question is, how many days is it going to take him to reach his 30 laps? That's what we had to determine. That's what we didn't know. How many groups of 6 or how many days did he need to swim 6 laps a day? Again, we knew he would swim 6 laps a day, but we did not know how many days it would take him. We also knew the total number of laps he wanted to get to was 30. We determined by skip counting by 6 that in fact it took him 5 days. In 5 days, 1, 2, 3, 4, 5, swimming 6 laps a day, Kenny will get to 30. 5 jumps of 6 makes 30, or 5 times 6 equals 30. It took Kenny 5 days to get to his goal. What do you notice? What do you wonder about? We want to nurture these skills in students. We want them to stop, think, reflect, and then communicate what they're thinking. We want to know, does this model make sense to them? Did it help them solve the problem? Did it make the problem any clearer for them? As they talk, don't stop them or correct them. They may say things that surprise you. Watch what they say, watch their gestures, listen to their language. They may talk about skip counting, they may talk about adding, they may talk about multiplying. You can wrap all these up and say that these were good observations, and here are some questions you could ask them. In this problem, we didn't know how many groups we would need. But how many were in each group? Did we know that? Where was that in the problem? When we use the number line to multiply, how is it different from when we use it to add? How is it the same? When you think students are ready and they've had some conversations, give them some tasks to do on their own. Let them know that you want them to model the problems they see, think about them, attach number sentences to them, and above all, communicate with each other and justify their thinking and tell you how they're making sense of the problems. You can find many problems if you go to stage 13 in the guided practice on your Symphony Math support page. And at the student page, you can put in demo, 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 and pull up any problems to project on your smartboard from stage 13. After students have constructed models and communicate, listen to see if they make sense of the everyday math that they're doing. Let them know that what they're working on here has to do with how addition is connected to multiplication, and let them know that by making models and talking to each other and thinking about what they're doing, they're helping themselves understand math and owning their own math education. As students go back onto the Symphony Math program, stage 13, you can see how they're doing by looking at your dashboard. If you go into individual students' use in progress page, you see red, yellow, and green informative icons. When you press on an icon, it lets you know the kinds of problems students are able to handle, the ones that give them some hesitancy, and the ones that are stumping them. If you see a lot of red, it's a signal to you to continue some offline work with your student and have them make models and talk, and above all, listen to your students. Have fun.